NEC 250.52 A3 addresses concrete encased electrodes and their use in grounding electrode systems. The code stipulates that reinforcing steel, the metal frame of a building, or other conductive materials that have direct contact with the earth need to be bonded together. These components must be connected to the grounding electrode conductor at the surface. A critical point is that the sole connection to the grounding electrode is to be at the service location. The purpose of this section of the code is to ensure that all grounding conductors are connected to the grounding electrode at the service entrance. The service entrance is the point where the electrical service enters the building. By having a single connection point for all grounding conductors, the code aims to establish a low resistance path to ground. This low resistance path is essential for safety and proper functioning of the electrical system. In cases where a concrete encased electrode is utilized, the reinforcing steel within the metal building is connected to the grounding electrode conductor at the service point. This connection is typically achieved using a bare copper conductor. This conductor serves as the link between the reinforcing steel and the grounding electrode system. The bare copper conductor is also connected to the neutral at the meter. Now let's consider table 250.66. which specifies the minimum size requirements for grounding electrode conductors. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. For instance, if the service entrance conductor is size number 4 AWG, the minimum grounding electrode conductor size is number 8 AWG. It's crucial to verify that the conductor used for connecting the reinforcing steel to the grounding electrode conductor meets or exceeds the minimum size specified in table 250.66. Let's say the number 4 bare copper conductor connects the reinforcing steel of the metal building to the grounding electrode conductor. And also, this number 4 AWG is also the service entrance conductor size. In this situation, the conductor complies with the requirements outlined in table 250.66. It's important to understand the hierarchy of standards. The NEC, or National Electrical Code, provides guidelines for electrical installations. Local inspecting authorities often interpret and enforce these guidelines. However, interpretations can sometimes vary. When evaluating an installation, it's essential to consider both the specific requirements of the NEC and any local amendments or interpretations. If the local authority insists that the building steel must comply with table 250.66, it's important to analyze the situation based on the code's intent and specific wording. If the conductor connecting the building steel to the grounding electrode system is adequately sized according to table 250.66, the installation is likely compliant. To summarize, firstly, NEC 250.52 A3 mandates the connection of reinforcing steel or metal building frames to the grounding electrode conductor at the service. Secondly, the purpose is to create a single point of connection for grounding conductors. Thirdly, table 250.66 dictates the minimum size of the grounding electrode conductor based on the service entrance conductor size. Fourthly, if the conductor connecting the building steel meets the requirements of table 250.66, it is generally considered compliant with the code. Fifthly, any concerns from the local inspecting authority should be addressed by referring to the NEC and its intent. When working with electrical systems, it's crucial to follow all applicable codes and regulations. Proper grounding is essential for electrical safety and equipment protection. If there are any doubts or uncertainties, it's always advisable to consult with a qualified electrical engineer or inspector.